Assalamu alaikum. You might have observed when a stone or pebble is dropped on still water, water ripples are formed. These water ripples or water waves spread in all directions. At any given time, if you take a picture of these water waves from the top, we observe concentric circles. These concentric circles are nothing but wavefront at that instant. In this video, we will discuss about wavefront, and we also learn about the Huygens Principle, which provides the new position of wavefront if you know its position initially. Let's go ahead. First, I'll tell you what is the wavefront. Wavefront. Wavefront is nothing but the locus of all points having same state of vibration. The locus of all points having same state of vibration. So what does it mean? You may find little difficult to understand. I will explain this with the help of a simple example. Now here I take the example of water waves. There is a still water surface and we drop a stone. Then see, this is the point where the stone hits the still water surface. In such case, water ripples are formed, which are in the form of concentric circles. They spread out in this way. Here, I have used the term concentric circle. What does it mean when we say concentric circles? It means circles with common center. Circles with common center is referred as concentric circles. So this is a wavefront. Now, to make it more understandable, I take this point here. From this point, waves are spread. Waves are spread. This is a wave. This is a wave. Here we have another wave. This another wave. Another wave. See all these waves. Now, when we have a wave, I think this is a wave. In case of a wave, this elevated portion or elevated part is referred as crest, whereas this depression represents a trough. So here I take the first crest in all these things. Okay, I haven't drawn it properly. I take the first crest, point on first crest on all these waves. Then I join them together, these points. So what I have obtained here is nothing but the locus. This is the locus and it provides me the wavefront. Well, I hope you have understood. Wavefront is nothing but the locus of all points having same state of vibration. See, these points 1, 2, 3, 4. These points have same state of vibration. All of them are taken in the first crest. So the locus of all points having same state of vibration is referred as wavefront. And the wavefront is of a different shape depending upon the shape of the source which has produced it. If I take a point, source at a finite distance, then it gives us this way. And here, wavefronts formed is nothing but spherical in shape. So, a point source at finite distance gives out a spherical wavefront. This is an example of a spherical wavefront. Spherical wavefront. If the source is in the form of slit, there is a slit illuminated by light, then it gives out a slit illuminated by light. It gives out the cylindrical shaped wavefront. So this is the cylindrical shaped wavefront given out by this slit illuminated by light. Correct? Cylindrical wavefront. Cylindrical wavefront. Now next, suppose there is a source of light located at infinite distance, then it gives out plane wavefront. Oh, it gives out plane wavefront. These are the rays coming out of a source of light which is located far away from us. Then it produces plane wavefronts. So here, if you look at all this diagram, you find that the wavefront, this is the wavefront, plane wavefront. The wavefront is always kept perpendicular. It is always located perpendicular to the ray. This is a ray of light. This ray, this wavefront. The angle between these two is nothing but 90 degrees. So they are perpendicular to each other. I repeat, wavefront is always perpendicular to the ray. That you can observe in all these cases. It's all about wavefront. I hope you have understood. Now let me tell you what does the Huygens principle say. It is the name of a scientist. It is pronounced as Huygens. It is pronounced as Huygens. It says that every point taken on a wavefront is considered as the source of secondary wavelength. And it also says that the forward envelope gives the new position of the wavefront. I repeat, every point taken on a wavefront is considered as the source of secondary wavelength. And at the forward envelope on this wavelength gives us the new position of wavefront at any given time. Now let me explain this with the help of a simple example. Here I take a source of light located at infinite distance. In that case, it gives out parallel rays. Okay, and here a line drawn perpendicular to these rays is nothing but a wavefront. Now this kind of wavefront is known as plane wavefront. Now if I take points on this wavefront, then these points acts as the source of secondary wavelength according to Huygens principle. So I name these points as P, Q, R and S. Now, at any given time t, suppose they travel with the velocity of light given by letter C, then the distance covered is taken as Ct. How is it so? Let me tell you. Here we know velocity is nothing but displacement divided by time. Here, these wavelets are said to travel with the velocity of light. So, velocity of light is given by letter C. Here, displacement is taken as R and time is taken as t. What is so? R, which is the distance or displacement covered at time t, can be obtained by cross multiplication. Here, Ct is the displacement covered by the secondary wavelet when they start from these points. I take Ct as the radius. Take these points here at time t. Suppose all these points have traveled to these new position. The distance between them is taken as r. Distance is taken as r. Is r. Now, I take this distance as radius and the point PQRS as the center. Then I draw a circle. I do the same with all these points. Clear? Then I have obtained these 4 circles. Now, if I draw a forward envelope which covers all these circles, now what I have drawn is nothing but a tangent which goes touching these circles and it acts as the envelope. Forward envelope. This forward envelope provides us the new position of the wavefront at time t. I hope you have understood. This is how one can use Huygens principle to get the new position and the shape of the wavefront at any given time. If you know its location and position, location and shape initially. Clear? Now I'll take one more example. Now this time I take a spherical wavefront. On this, I'll take 2 points. To make my work easy, I name this as P and this point as Q. Now, these points act as the source of a secondary wavelet according to Huygens principle. And if they travel with the velocity of light, that is c, then they cover a distance Ct at time t. It is taken as r, which acts as the radius. I do the same to this point as well. It also travels a distance equal to Ct divided by letter r. Now, by taking this distance as the radius, I draw a circle. I do the same here as well. I draw a circle. Then a forward envelope gives me the new position of the wavefront at time t. This is how one can easily obtain the new position and the shape of the wavefront. If you know the initial position of that particular wavefront. I hope the video is useful. If you have any kind of doubt related to the topic, then you put your questions in the comment section. Thanks for watching.